This is the final video for lesson 14.2, and it's about arithmetic series, and we're going to find some partial sums. And of course, if you haven't seen the previous videos for chapter 14, you might become lost, confused, or frustrated, so you can go to the Algebra II playlist and watch them in order, or you can click on the links and watch the ones you think you need. We can find partial sums of arithmetic series. An arithmetic series is a series that's associated with an arithmetic sequence. And the sum of the first 10 natural numbers would be 1 plus 2 plus 3 plus 4, plus 5 plus 6, all the way up to plus 10. So we know a sub 1 is the 1, and a sub n would be the 10. We know it ends here. This is an arithmetic series, and it's a sum of terms that come from an arithmetic sequence. And there are two formulas we can use to find the sum of the first n terms. Here's the first one. It's the sum of the first n terms of an arithmetic series is given by this formula. So this is when you know the first term and the last term. That's when you would use that formula. And it's helpful, remember, when you know the first term and the last term. This formula is when you don't know the last term, okay? If we don't know the last term of the series, we substitute the formula that we know from the previous videos, a sub 1 plus n minus 1 times d, for the a sub n. Okay? It's when we don't know it. So here it is. So if you look at this formula, and you look at this formula, you can see how we added this on. See? We have a sub 1, and we're adding another a sub 1, aren't we? So we have two a sub 1. See how they got that? And then we're putting the n minus 1 times d in place of the a sub n that we don't know. See, because we don't know the last term. So we can find the sum of the first 100 natural numbers, 1, 2, 3, 4, 5, all the way up to 100. And we would use this formula because we know the last term is 100. See? So we know a sub 1 is a 1. We know that a sub n is a 100. We also know that n equals 100 because it's the 100th term. We're going from 1 to 100. So we use that formula from the first theorem, knowing the first and last, okay? And we substitute in our numbers. So we know n is 100, so we've got s sub 100. And we put 100 divided by 2 here. And we've got 1 plus 100, because it's a sub 1 plus a sub n, and we know that's 100, okay? That's going to give us a 50 times 101, and that's going to give us 5,050. So the sum of the first 100 natural numbers is 5,050, all right? We can find the sum of the first 14 terms, so that's partial, isn't it? We're not finding the sum for the entire thing. It's got a and so on, which tells us it goes on for infinity. So these are partial sums. We're only going to find the first 14 terms of this arithmetic series. We know a sub 1 is a 2, and we know d is a 3, the common difference, because 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3. So we know for certain that the d is a 3. And n is 14 because we're doing the first 14 terms. Now, because we don't know the a sub n, that last term, we're only doing the first 14, we're going to use this formula. We've got the formula right here, and we're going to substitute in these numbers into the formula. So we've got a 14 here for n. We've got a 14 here for n. We've got a 2 for the a sub 1. We've got a 14 for the n again, and we've got a 3 for the d, all right? We just do the math. 14 divided by 2 is 7. 2 times 2 is 4. We're going to add it to 13 times 3, okay? Remember to multiply first, all right? That's going to give us a 4 plus 39 over here, so that's a 43. 7 times 43 is 301. So the sum of the first 14 terms in this series is 301. Okay? we can find the sum of the series. For this one, we used the Greek letter sigma for sum notation in the last video or so. So you should know what this means. It means we're going to go from the first term to the 13th term, and we're going to use this to find the term. So we plug in our numbers. We start with a 1, because we're going from 1 to 13, and we find the first few terms to be able to find the sum of the series, and we get a 4 times 1 plus 5, that's a 9. We get a 4 times 2 plus 5, that's a 13. 4 times 3, and we could go all the way up to 13, okay? But here's the first few terms. We can see the difference. 13 minus 9 is a 4. 17 minus 13 is a 4. So we know our D is 4, and we know our A sub 1 is a 9, because that's the first term. We also know that we've got N equals 13, because that's what it goes up to. It tells us right here, 13. We don't know A sub N, so we're going to use that second formula from the second theorem, okay? That formula from the second theorem, this one. And we plug in our information right here. So we've got 13 for N, 9 for A sub 1, 13 for N, and 4 for D. And we do our math. I know this is not going to be even, so I'm going to leave it to the end, the fraction. I'm going to do inside the brackets first. 2 times 9 is 18. We're going to add it to 12 times 4, which is 48. That's going to give us a 66. But we can cross-cancel, can't we? We've got a 2 here and a 66, so that could turn into a 1 and a 33 to make our lives easier. If you're using a calculator, you may not care. Just do 13 times 66. But we end up with 429, okay? So do you see how I found the A sub 1, the D, and the 13? We used this to find a few terms and plugged in 1, 2, I don't know, maybe the third or fourth one. We know it goes up to 13, so N is going to be 13. And we saw the difference between them, the common difference, so that gave us D equals 4, okay? Let's try it one more time. We can find the sum of the series. Now it's going to go from 1 to 20. And we read this as the sum of the quantity of negative 2 times N plus 21. As it goes from 1 to 20, we can see it goes from 1 to 20. We're going to use this to find the first few terms. So we're going to put a 1, because that's where it's starting from, and then a 2, and then a 3, and see what we come up with. And we get negative 2 times 1, which is a negative 2 plus 21. That gives us a 19. Then we get a 17. Then we get a 15. So now we can see that A sub 1 is 19, okay? And we can see 17 minus 19 is a negative 2, and 15 minus 17 is a negative 2. We also know that N is a 20. It tells us right up here. So now that we've got this information, and we don't know the last number, so we're going to use the second formula right here. We plug in our numbers. We've got 20 for N, 19 for A sub 1, 20 for N, and negative 2 for the D. 20 divided by 2 is a 10, isn't it? So we can get that out of the way. 2 times 19 is 38. This is 19 times negative 2. So we're going to have a negative 38. And when we add it to the 38, that makes a 0 pair. 38 plus a negative 38 makes a 0 pair. It cancels out. So now we have 10 times 0, which is 0. So the sum for this series is 0. Okay? Make sure you watch your signs, and make sure you multiply this before you add them together. Okay? You don't want to end up with the wrong amount, right? All right, one last thing. This is actually brought up in calculus, but it was in the book, so I thought I'd mention it. Our harmonic sequence is a sequence whose reciprocals form an arithmetic sequence. So it'd be like 1 and a half, a third, a fourth. If we flipped these around, we'd have 1, 2, 3, 4. Do you see that? We'd have 2 over 1, 3 over 1, 4 over 1. See that? So that's a harmonic sequence, okay? Our next video is going to be a new lesson. It's going to be 14.3. I'm going to start talking about geometric sequences, and we're going to find the common ratio, all right? Let me know if this helped you. I hope you wrote those theorems down. If not, I would go back and pause the video and write them down because they're going to be very helpful. And remember that this one is when you know the first and last, and this is when you only know the first, okay? You don't know the last one, all right? And put that into your notes so you can use it. I'll see you next time. Bye.